All right, amazing AP Stats students. Let's rock. This is assignment 3. Here we go. Firstly, look at the directions here. Don't overlook this because you don't have to do that much. Determine whether or not the conditions have been met for a T procedure. First one is about how many pairs of shoes a teenager has. So think conditions. Oh, look, it says random. Okay, so it's random. Check. Now, is it normal? Uh-oh, there's only 20 of each sample. That's not enough. That's not 30. So then you might think, oh, well, then I should look at the distribution and see if it's skewed or if it has outliers. And so I've kind of just drawn a curve over the top of the stem and leaf plot. The female one looks pretty, I don't know, flat almost, but there's no outliers. It's not skewed for sure. The male one, if you draw a curve over the top and then like turn your iPad sideways and look at it, um, you can tell there's a tail. This would actually be the right side if you turn it, because the numbers are getting bigger as you go that way. So it's skewed. It shows skewness, so we're not sure that the data is normal. So that's what's wrong with it. It would be independent because 20 is less than 10% of all female and male students, but it's not normal. Next one, what's not normal about this, or sorry, these directions still apply for number 41. It has countries, Islamic countries from around the world. It shows you the percentage in those countries of literacy broken down by males versus females. I counted it up. There are 17 countries. Um, okay. And that's too small, right? That's not 30. Um, uh, so that's actually my second bullet point. It's not 30. So what I actually did is I took the time and I put all of this data in my TI-84 and I made these box and whisker plots. And sure enough, the plot for males has 2 outliers. So that's a problem. The female one looks decent. It doesn't have outliers. Now let me just show you again. So in stat, in edit here, I have the data in list 1 and 2 right there. And I took time, made sure it was that data right there. Then I turned on both of these at the same time. You can do this on your TI-84. I gotta make this list 1 and list 2. Then I hit graph, zoom, stat, and there they are, which I've got right over here. Okay, so that's how you do that. Take your time and do that. Okay, so I'm having troubles grabbing my, there we go. It's also, this one's sneakier, maybe you didn't catch this. It's also not independent because I Googled this. Is 17 countries more than 10% of all Islamic countries? Turns out it is. I Googled it. There's approximately 50 Islamic countries in the world, and 17 is much more than 10% of 50. 10% of 50 is, drum roll, 5. All right. Here we go. 43. Is drinking red wine better than white wine? Apparently, when you drink wine, it gives you polyphenols that go into your blood, and it's good. It reduces the risk of heart attacks. So this has been a common thought, accepted practice that like a glass of wine a day might reduce your heart risk. So they're comparing men that some of them drink red wine and some of them drink white wine, and they measured the polyphenol in their blood after they did that. There are 1, 2, 3, 4, 5, 6, 7, 8, 9 data points for each. Just even at the outset, I looked at these, I was like, look at this. All the red wine numbers are positive and some of them are pretty big. And all the white ones, well, some of the white wines, I have 1, 2, 3 that are negative. I have this one's practically 0. This one's practically 0. So right off the get-go, I'm like, it looks to me like red wine does provide more polyphenols. So, first question though, it gives you dot plots down here. It says, are the centers of the two groups similar or different? Well, um, the green line is the median for both of these. So the red wine had a median of about 6. I just went 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 because there's 9 data points. So the median there is about 6. And 1, 2, 3, 4, 5 gives you a practically 0 for 0, or I guess I put a 1. So they're not the same. They're quite different. But the spreads are pretty similar. Um, the range is a measurement of spread. So for red wine, I did 8 minus 0, which is about 8. For white wine, it's 4 minus -6, which gives you a 10. So 8 versus 10, pretty similar. Um, Also, in the calculator later, we're going to actually find standard deviation because I have this in the calculator. I'll show you they are pretty similar. B, we're going to make a 90% confidence interval. So the mu R is the average polyphenols in red, R for red wine, W is for white wine. We're going to do a 2-sample T interval for red minus white. The average red minus the average white. Is it random? It said it was. The sample size is only 9. Oh my goodness. So we should make box plots again. And I will do that, and I'll show you there's no skews and no outliers. Before I do that, let me just touch on independence. There's only 9 people in each sample. 9 is far less than 10% of the population of men that drink wine, or 90 is less than the entire population. So let me show you the box and whisker plots. So I have put the data into this calculator into list 1 and list 2, and I made sure that it's accurate. Then you go to stat plot. You got to turn this bad boy on. We want to choose this one because it gives me outliers. Okay, then I also want to go and turn on the second one. Just do both of them at the same time. Boop, boop, boop. That one, and now I'll do list 2. They're set up, so now if I do zoom 9, it will show me both of them. I don't see any outliers, and neither whiskers, none of them look terribly skewed. The blue one might be a little, but it's nothing like that's a slam dunk. Okay, so that's how I knew this. Okay, then here we go. We're gonna write out the word. This is what you would plug into the calculator if you had to, but you should show these numbers on an FRQ and then revert to the button on the calculator. Okay. Um, oh, sorry, my notability. So where did I get these numbers? Back to the calculator. I got X bars and the standard deviations from the calculator. So to do that, I would go stat calculate, one variable stats. I'll start with the first list. And so there I go. There's my X bar, 5.5. That's the red wine. And SX is 2.51-ish. Okay? And you can jot those down. If I do it again for the second list, there they are. And look at that, folks. The X bar is practically 0. It's 0.23 repeating. And S of X is 3.29. So when I show you here, that's where I got these two numbers. Maybe I can split screen. Sometimes it doesn't work too well with the online calculator. Yeah, kind of like that. But that is where I'm getting these numbers here that I'm filling in right here, okay? You can still see it right there, the 0.23 and the 3.29. Okay. One little word of caution that I actually overlooked at my first time through this. This is a T-star because it's a t-test. Okay, so I have to look up 90% and I have to look up the degrees of freedom, which will be 9 minus 1, which is 8. Okay, both samples were size 9. So degrees of freedom is 8, so I got to look up 8 on the side and go over and look up 90% on the bottom and come up and see where those two cross on my table B. So let's do that. Here's table B. Here's 8. And where's 90? 90 is on the bottom. So there it is. That is the number I had filled in already. So that's my critical value this time. Again, based on degrees of freedom of 8 and 90% confidence where they intersected. 1.86. So that went right there in the middle. And then both samples were 9. So you do need to just write this out, but then let the calculator do the grunt work for you, the heavy lifting. So again, I have all the data in here. So the button is number 0, 2 sample t interval. I have the data in the calculator, so I'm going to click on that one. And I have the right lists, list 1 and list 2. It's all set. And you do not pool. You just never need to pool. Calculate. There you have it. Okay. Now, let me show you. I wrote it. Let me see if I can get that back up. Well, you can kind of see it now. 2 point, yeah, you can see it off the edge there. I wanted to see, do you see there the DF? It says 14.97. That sometimes concerns kids. They're like, what's going on? I thought the degrees of freedom was 8. The calculator kind of sometimes does its own methodology for degrees of freedom. And the bottom line is you don't have to worry about it. The differences are going to be minute and small, where maybe it's only going to affect small decimal approx. Um, it's only going to affect like the thousandth or the 10,000th decimal points. So it's not anything to worry about. If you show your work like I have on an FRQ, and you have convinced me that you know what you're doing, okay? I also then wrote it as this. This here is the point estimate, and then you can do a little math. You can do this minus this. That's the margin of error. The conclusion sentence is in blue. We're 90% confidence the true mean difference in polyphenol levels of red minus white wine drinkers is between those two numbers. Then the last one here is, does the interval in part B suggest red wine is more effective? Um, Meaning if red wine is more effective, then when I do this subtraction, red minus white, it'll be a positive number, right? But if red wine is not more effective, the answer would be 0, right? Red minus white would be 0 if they're equally effective. 0 is not oh, excuse me, I have a slight discrepancy here. 0 is not in my interval, right? My interval goes from 2.84 to 7.69. 0 is not in there. So everything in this interval is positive. So everything um, suggests that yes, red wine does provide more polyphenols because 0 is not in there. It supports the belief that polyphenol levels is different for men who drink red wine versus white wine. I might even say not different. I'd even go further and I'd say greater. Okay. Last one, I think. This is about kids who work in the summer to pay for college. It's comparing males and females. Big sample sizes for both. Here's the averages that each group made per summer, and here's the standard deviations. Part A, how can you tell from the summary stats that the distribution of the earnings in each group is strongly skewed to the right? A graph of the data shows that there's no outliers. The use of the procedure is still justified. Why is it still justified? So, um, here's why it's skewed, first of all. So I put the women's average, female average right here, and it's skewed right. Why is that? Because earnings cannot be negative. So here at 0, there's a hard edge. You cannot go to the left of this. It's not possible. Yet, if I look at the standard deviation, it's practically if you go one standard deviation that way, you're practically at 0 because this is almost equal to this. So I can't even go 2 standard deviations because I'm into the negatives. So that more or less forces me to understand that there's a couple outliers, not outliers, there's a couple bigger numbers over here that are skewing the data to the right. It just has to be. There's some kids in the summer that are working their tails off, 60 hours a week, making 5, 6, 7, 8 grand or more. Okay. Um, but why can we still use a T procedure? because these are large enough, okay, um, to satisfy the CLT. Okay, they're way more than 30. B, we're going to make the 90% confidence interval. I'm glossing over this. Let's just say they're met. I already talked about the CLT. It's random and independent. Moving on. Where did I plugged in the numbers. Okay. Let me show you how. This number is the male average. This number is the female average. Okay. When I subtract those, this will be my point estimate. So this shows, based on our data, the males are making $524 more than the females on average. Then, again, where does 2.145 come from? Good question. This is going to be the T star again, okay? I have to look up the smaller sample size, so my degrees of freedom, df, is going to be 621 minus 1, which is 620, but that's not on the table. I have to go up. How far up? And I'm going to cross with 90. I go way up to, look at that. It goes from 1,000 to 100. So um, I'm going up to 100, and where's my, wait a second. I'm doing, that's not 2.1455. I don't think it is. Unless I'm missing something. It is 9 because I'm seeing this. Is that what you guys are seeing? Hold the phone. I wonder where I got that 2.145. Maybe that's a mistake. Hold that thought. I'll come back to that. All right. Anyways, regardless, that is going to be, this whole chunk is going to be my margin of error. And where do these other numbers come from? Here's the standard deviation for the females. Oh, sorry. Here's the standard deviation females. Here's standard deviation males in the respective sample sizes. At this point, folks, I would use my calculator to have it produce the interval right here for me. Okay. Let's do that. I need to be able to see it though, Fag. All right. I think I had the data entered. Let's see if it kept it. If I do stat tests 0 and I do the stats. Oh, nope. I have to enter these by hand. So kind of annoying. I get it, but take your time. 1884 and 52 cents is the average for the males. Their standard deviation is 1368.37. Oops, I hit the tangent button. Sample size for the males was 675. Average for the females, 1360.39. And 621. 90%, don't pool it. All right. All right, yeah, so those numbers match. See, I'm looking down here at those numbers. My pennies are a little bit off, but I would not quibble over these tiny mistakes again. I think a lot of it comes back to these T's, because you can see, look at the degrees of freedom that it's listed on my calculator there. 1249, that's like the two sample sizes added up. It's something like that, okay? All right. Oh, yeah. Okay. I'm just checking back in on this 2.145 that I wrote down. And it is it is what I thought it should be. I was looking at the wrong thing. You see the 1.660 that I had there? That would be more appropriate than whatever I had. written down. Okay. So then your conclusions there. Part C, we're 90% confident the true difference in summer incomes, males minus females, is between those two dollar amounts. All right. Think we're done, folks. Woohoo!